Ladies and gentlemen, dear friends, above all, I wish you a happy new year. Dear friends, welcome to the IR conference on compressors and refrigerants. The conference has a very nice 10th anniversary. For the first time, the conference is held virtually. COVID-19 2021 has changed our life. Safety now is the priority. My name is Peter Tomlin. I am responsible for the conference organization. You can find a choice of presentations in our virtual lobby. You can follow 44 presentations in 9 sessions, the invited paper on hydrogen, and the IAR Commission's meeting. The conference will be recorded and each presentation can be followed later. In the virtual lobby, you have a choice of sessions, choice of presentations, and the possibility to ask questions using Slido. Questions will be answered by authors after presentations. Why is the conference held in Slovakia? Slovakia started compressors production in 1949 or 70 years ago. Production started in companies Maneta and Kalex. Later came companies Samsung, Danfoss, and at present time Sekop Compressors and Embraco Nidec. Slovakia is one of the biggest compressors producers in the world with nearly 2 compressors produced per capita per year. Finally, I would like to thank our platinum sponsor, company Sekop, our gold sponsor, company Embraco Nidec, and silver sponsor company Daikin. Thanks to our sponsors for their support of the conference. We have a very rich program. We should start the plenary sessions. I would like to introduce Professor Juraj Hromković, Slovak scientist of information technology and education at the Department of Computer Science at ETH Zurich, who will introduce the personality of Professor Aurel Stodola, the Slovak scientist called the father of the steam turbine and designer of the first water-water heat pump constructed in Zurich in 1928, which works already 90 years. I would like to invite the presentation of Professor Hromković. Dear Juraj, please, it is your turn now.
Ladies and gentlemen, dear colleagues, it is a pleasure for me to be allowed to say a few words about Aurel Stodola, one of the pioneers of mechanical engineering. Because you may know much more about him and his achievements in mechanical engineering than me, let me speak about other dimensions of his personality. Aurel Stodola was a polymath, and he applied his knowledge in the education at ETH. He even wrote texts about special relativity theory, evolutionary biology, especially population genetics, psychoanalytics of Sigmund Freud, and he was also very much interested in politics and education. And it means he really asked her students.
First, tell you a few words about the International Institute of Refrigeration, then about various environmental issues. First, because this conference is an IR conference, International Institute of Refrigeration Conference, I would like to briefly present you what we do. And of course, it is in connection with the following issues I would present: the impact of refrigeration on climate change, the refrigerant issue, the energy issue, and the increasing need we have regarding food losses and air conditioning issues. And then the actions at the international level, the Paris Agreement, the Kigali Amendment to the Montreal Protocol, the new involvement of the United Nations in the refrigerant sector. And now actions at regional and national levels in the European Union, in other developed countries, and in developing countries. And I would like to insist at the conclusion about the importance of revised nationally determined contributions, which is the key issue this year in 2021. So what is the International Institute of Refrigeration? It is a relatively old organization founded in 1908 as an intergovernmental, so there are countries which are members, science and technology-based organization. And our mission is still the same: dissemination and promotion of knowledge on all refrigeration technologies and issues. And when we mean all the refrigeration technologies and issues, it means food quality and safety from farm to consumer, comfort in homes and commercial buildings, air conditioning, health products and services, and you know the issue, for instance, for vaccines, low temperature technology and liquefied gas technology, energy efficiency, and the use of non-ozone depleting and low global warming refrigerants in a safe manner. And as you see, we are perfectly corresponding to the various sustainable development goals, and we are partners of the United Nations in order to develop the sustainable goals, the United Nations Sustainable Goals. We have an international network with 59 member countries, including Slovakia. We have corporate and private members, companies, universities, consultants, and we have experts in all our member countries in all the continents. And you see on the bottom the various partnerships we have, especially with the United Nations organizations. What do? We collect information, we put it in the FreeDoc database with about 110,000 references. We have a scientific journal, the International Journal of Refrigeration, and some of the presentations you will have today could be perhaps in the future put in the International Journal of Refrigeration. We publish informatory notes, conference papers, books, guides, policy briefs. And of course, we organize conferences such as this one in partnership with our local organizers. And I would like to thank Peter Tomlin to have organized this conference for many years now. And we are involved in the research and development projects. We have reference documents such as the International Dictionary of Refrigeration. We have a newsletter, we have a expertise directory, a waitress directory, personalized search services, and so on. And here you have some of our informatory notes, and I will come back to some of them during my presentation. A lot of them are related to climate change, to environmental issues, the impact of refrigeration on climate change. Well, what is the impact of refrigeration on climate change? First, we have an increasing urban population, not only an increasing population in developing countries, but also a urban population which is increasing. And thus, we have increasing needs. Food, we have to feed people, and it is still an issue in developing countries. We have about 800,000 people who are undernourished. It is the health products issues. I mentioned the vaccines. You certainly know the logistics, the cold chain logistics, which is necessary for vaccines, and it is clearly a key issue now this month. Air conditioning, information technologies, biotechnologies, all a lot of technologies, a lot of users, modern users as well as traditional users need refrigeration. And the main issues we have are related to refrigerants, the energy, the cold chain, air conditioning. And I will not go too much into details, but certainly in the future also progressively recycling with the circular economy of materials which are used in refrigeration equipment. What's the refrigerant issue? Well, you certainly know that the refrigeration issue represents, when there are leakages of various fluorinated gases, 2.9% according to our estimations of global CO2 equivalent emissions. As you know, HCFCs will be phased out. HCFCs will be phased down in the future. HCFCs in 2030 for developing countries. It is already the case in developed countries. HCFCs until 2045. Many measures are already taken. And thanks to the Kigali Amendment, we are already moving in the right direction. As you know, we have serious steps, 2030, 2050, in order to obtain a carbon neutrality in the middle of the century. And the actions and refrigerations are, we can consider on time for that. You have here the impact of the refrigerants on climate change, various CO2 equivalent emissions, and you see the progress we have between CFCs, then HCFCs, then HFCs. Now we are currently decreasing the use of HFCs, and that's fine. The second main issue is the energy issue. It is more important than the refrigerants issue. It represents about 4.9% of global CO2 equivalent emission for all the refrigerant users, including air conditioning, for instance. Here you have a presentation of the various kinds of greenhouse gases emission due to the refrigerant sector only. And as you see, most of them are due to electricity with CO2, methane, and N2, zero, and CO2. And then CFCs, HCFCs, HFCs. Well, so however, even if it is the main issue, it can be very different from country to country depending on the energy mix. However, in any case, at an international level, refrigeration represents about 20% of global electricity consumption. And as it is increasing, this proportion is increasing, the impact on energy infrastructure is in any case huge and must be contained, even if we have more renewable energy. And the energy of the system the whole systems, such as buildings, factories, vehicles, is at least as important as the energy efficiency of refrigerant systems. Because envelopes, for instance, insulation are very important, and we cannot only take into account the energy efficiency of refrigerant systems, but think about all the systems, the whole systems. And also, I would like also to remind you that we have increasing needs. A reliable cold chain is necessary for food safety and health. And for instance, according to the WHO, about 40% of the world vaccines are unusable due to a lack of such a chain. As I told you before, it is still an issue for the current vaccines because of the COVID-19. The world population will increase by 2 million by 2050, taking into account that we already have about 800,000 people undernourished, and the elimination of food losses and waste could feed up to 950 million people, according to our estimations. Moreover, environmental consequences of food waste outweigh the environmental consequences of the current cold chain. Refrigeration can have a positive impact on the environment. I would like also to insist on the fact that we also need air conditioning. It is a tool for adapting to global warming, and in any case, it will increase. And you have the figure with the stock of air conditioners by country, region, end of 2016. As you see, we have a main issue with developing countries, emerging countries. And other countries, such as the European Union, I mean, it is relatively small now, but it is increasing too. And on the left, you see the refrigerated warehouse capacity in cubic meters per urban resident. And as you can see the difference between, for instance, Philippines and New Zealand. It is, and of course, Philippines will increase its capacity. It is very necessary for its health, for its feed. However, fortunately, we have actions at the international level. We have the Paris Agreement. As you know, currently, we are about 1 degree Celsius higher than in the pre-industrial period. In December 2015, which was the Paris Conference of the Parties, where we agreed with the Paris Agreement, it was decided to avoid more than plus 2 degrees Celsius and, if possible, plus 1.5 degrees Celsius. It means only 0.5 degrees Celsius compared to today should be allowed. And unfortunately, since the Rio Convention in 1992, where the climate change was recognized as a main issue, almost no efforts were made except in the European Union with the Kyoto Protocol. So it is now a challenge for all the countries to reach these goals of the Paris Agreement. Do you hear me? It's okay? Okay. Well, you must understand that according to the Paris Agreement, there is no obligation to countries. Each country must define its own goal and its own way to achieving its goal. Currently, we have the clear majority of the countries which ratify the Paris Agreement, and I'm very confident that the other ones, and for instance, the USA, will ratify the Paris Agreement, even if they before the adoption of the Paris Agreement, each country had to present its intended nationally determined contribution, INDC. So it is their goal, but unfortunately, INDC are imprecise. They don't give any detail on the way to reach their goals, and they are not sufficient. Even if the targets of the INDCs are met, the result would be 3.56 degrees Celsius compared to the pre-industrial level. So in any case, it is not enough, and it is not detailed, so we don't know how each country will reach its goal. We can make promises, but we have to reach the promises. So we are expecting the presentation of new INDCs in Glasgow in November 2021. As you know, we should have a conference of the parties on climate change in November 2020. Because of the COVID-19, it was postponed to 2021. And now the commitments we had in Paris in 2015 is to present new INDCs in Glasgow in the next conference of the parties on climate change in November 2021. Currently, we still did not receive a lot of contributions, mainly very small countries, so it is not enough. But several countries, even if they didn't present these INDCs, have already declared carbon neutrality by 2050. For instance, the EU, UK, because UK is following the EU, even if it left the EU, or China, for instance, 2060. So we have to wait on their practical proposal, but there is a clear will to reach the carbon neutrality at the middle of the century. Well, secondly, we have the Kigali Amendment to the Montreal Protocol, which had a very positive impact. And you see here in the graphics how the Kigali Amendment is important regarding the reduction of CO2 emission. And we must be more confident in the success of the commitments in this Kigali Amendment compared to the Paris Agreement, because these commitments in the Kigali Amendment are very precise with the control tools of the Montreal Protocol that have proven to be efficient. So now we have these two goals, links with the Paris Agreement, with especially the energy issue, and the Kigali Amendment for the refrigerants. However, energy efficiency was considered as a key criterion for selecting and financing new projects, but no practical agreement was reached within the Montreal Protocol meetings. No link was established, unfortunately, with the tools of the Paris Agreement. So we should have used the opportunity of the Kigali Amendment to also reach goals in the energy efficiency with the equipment, but unfortunately, it is still not really the case. We have plans to phase out HCFCs by 2030 in developing countries, but unfortunately, they have not been modified to simultaneously start phasing down HFCs. And of course, we should avoid substitution by high GWP HFCs, because afterwards we will need more time to phase down high GWP HFCs if we don't do it now. So it's not perfect, but of course we are working on that. And fortunately, we have a new involvement of the United Nations and the refrigerant sector. Before 2019, sincerely speaking, there was no strong involvement in the refrigerant sector with FAO, for instance, regarding the cold chain for food, with the UNEP, of course, except the ozone team, the World Bank, and despite all our efforts for decades. We had a very important report written by the International Energy Agency in 2018, and the IAEA participated to the redaction of this report. It was a report on air conditioning, and it showed that air conditioning uses are clearly fast increasing, and it would be main issue for the next decades regarding the Paris Agreement if we don't modify the way we are increasing the air conditioning uses. And in 2019 was a very important year. First, we obtained some communication activities with especially the United Nations Environmental Programme and, for instance, the World Refrigerant Day, which was decided, and the first one was in June 2019 with ASHRAE and UNEP helping us for that. June 26th, and of course, we'll continue this World Refrigerant Day in 2020, and we'll continue this year. We had a G7 declaration in August 2019, pointing out the importance of the ocean sector regarding climate change. We had the UN Secretary General declaration in September 2019, mentioning food and vaccines as key issues for sustainable development. We had the Conference of the Parties to the Montreal Protocol with the Rome Declaration in November 2019. It was prepared by FAO, UNEP, Italy, and of course, we helped them to prepare this Rome Declaration, emphasizing the importance of the cold chain for the sustainable development. And at that occasion, we also signed a new partnership between UNEP and IAEA. And the General Assembly of the United Nations Environmental Programme also mentioned the importance of the ocean sector for a sustainable development. And it's important because within the UNEP, of course, as I told you, we have some people who are very involved on these issues, the people who are involved in about the ozone, stratospheric ozone layer with the various ozone offices, but well, it was not endorsed by all this organization, especially the people who are in charge of climate change. Now it has changed. In 2020, we signed a partnership with the International Solar Alliance, which is a new intergovernmental organization trying to develop solar energy. And of course, the partnership will try to develop solar refrigeration in developing countries. And we have also actions with the initiatives of the World Bank, for instance, in Rwanda, Bangladesh. We are currently discussing with them various projects in these countries. And of course, afterwards, in South Asia, in Africa, Latin America. So now, clearly, sustainable refrigeration is an international priority, and we're very pleased with that. Of course, it is the result of all our efforts. It's important, but now it has to become a national priority. It is first the case in the European Union. As you know, the European Union is a forerunner of many environmental policies, and so is the UK, because the UK is still trying to continue its actions it had within the European Union. And clearly regarding refrigerants, the European Union is in advance to other countries. We have the F-gas regulations, we had some national measures in some countries, and it is clearly a success regarding the phase out of HCFCs, of course, but now also the phase down of HFCs.
Didier, you should come to the closing. Your 30 seconds.
It's okay. We will have a revision in 2021 with possibly stronger constraints, and in any case, with complements after the 2030 deadline. So, and we also have some training of technicians which are encouraged, and we are also working with them for that. Regarding energy policy, we have an increasing energy intensity, and some actions are already devoted to refrigeration. I mentioned, for instance, an action we have on energy storage with the European Union, CryoHub. Also, you have the graphics. Food waste also is important, And progressively, there will be certainly some new obligations regarding food waste, even if it is less than in developing countries. Other developed countries, phase out of HCFCs are achieved, phase down of HFCs already started. It is important to understand that we had changes to standards and regulations which now facilitate the use of flammable refrigerants, which will replace high GLP HFCs. And of course, currently policies concerning energy consumption are various and complicated, but this will certainly evolve in the near future. Regarding developing countries, it is certainly the main issue. Some large emerging countries such as China and India are implementing actions concerning the promotion of low global warming potential refrigerants, such as hydrocarbons and renewable energies. But much remains to be done, and moreover, the strategies of most developing countries are still unclear. And also the needs in these developing countries are increasing. But international initiatives to help these countries are underway, in addition to the traditional actions of UNEP or UNIDO. Promotion of CO2 as a refrigerant, for instance, solar energy, actions of the World Bank on the CORCHI. So my conclusion is that we have major challenges for the next decades. The increase of the refrigerant equipment, the phase down of HFCs, the energy consumption, the food losses. And currently, apart from the case of refrigerants, there are few clear policies, but we have fortunately an international will. The IR has recently signed new partnerships, for instance, for that. But now the key issue is new NDCs. And we need to convince countries to include refrigeration policies in these NDCs this year. So become a member of the IR will have a lot of advantages, and you have on the screen a lot of advantages, but of course we are at your disposal to help you to see all these advantages. You can see also our website, which was totally renewed last year. And I would like to thank you for this occasion to present these main challenges. Thank you.
Thank you, Didier, for the nice presentation. And we can see that there are several questions, but we do not have time on all of them. But maybe the first one: do we need, besides F-gases and other legislation, specially aimed on alternative refrigerants with low GWP under 150, based on environment or safety?
Well, personally, I consider that regarding, at least in Europe, I mean, it is different in other countries. In Europe, we already have, I think, a lot of regulations. The main issue we have discussed at the European level, in addition to the current F-gas regulations, is the fact that some training could be mandatory, because we have some safety issues for alternative refrigerants, for instance, ammonia, CO2, hydrocarbons. We have some safety issues. And training and certification is possible, but not mandatory for these kinds of refrigerants. We already have some standards for flammable refrigerants. I think that they should be now implemented in the various European countries. A part of the European level, you have to implement all these regulations at the country level. And I think that in the case of the European Union, now the problem is at the country level much more than the European level. Regarding the other countries, well, we can detail all the issues for each country, but each country is different. So it is, in my opinion, now at the country level that we have to really implement the strategies.
Okay, thank you very much for this answer. But due to we are behind the time and we have to continue maybe after the session. So I would like to thank you for the presentation and the answer. And I would like to invite Alex Pachai with the presentation about safety work with refrigerants. Alex has now been working for your Johnson Controls Denmark for 20 years and held different positions. Alex has worked developing CO2 systems, chillers, and heat pumps using HC refrigerants, water vapor compression chillers, and high temperature heat pumps reaching temperatures over 180 degrees. Alex is chair also of the IIR Commission on Safety. I would like to invite the presentation. Dear Alex, please, it is your turn now.
Thank you. Thank you for the nice presentation, and Happy New Year to everybody participating in this very interesting meeting. My presentation will be about the IIR working group refrigeration safety, and that means all types of refrigeration systems, including all different types of refrigerants. And it has never become more important than it is now. The first steps, I can see my slides do not, here it comes. The first steps was taken back in 2003, but due to different things, it didn't really happen, and it didn't really get off the ground. So after a lot of push and force and back, we got back in business in 2019, and we tried to start up, and we are expecting a second steering meeting here in the beginning of this year. Why do we have to have a working group on safety? It's because we are having a lot of new working fluids, and they present a lot of different topics that we need to be aware of, such as toxicity. There is breakdown products in the systems, and there is other things that we need to consider. There is new systems. For example, you can take the new CO2 systems, which is actually not so new anymore. And then there is, for example, water vapor or air cycles. They are also new. And we need to know about this. One of my points I want to make is that it's important that the technicians that are working on these fields, they need really a lot of training to be up to speed to the development. Because if we look at the IEA, they say that 30% of the measures that we need to take to reach the 2050 goals is energy efficiency gains. 30% of energy we have to cut away just by increasing the efficiency. That's a lot, ladies and gentlemen. And then there's a whole set of new temperature regimes. When we are coming over 120 degrees in supply temperature, there is a lot of regulations that we have never been used to work with. But if you look into steam preparation with boilers, there is a lot of rules, and we have to comply to some of these rules as well, because we are also in pressurized water. And may I remind you that steam is also very dangerous, although it's water. And another challenge we have is that a lot of qualified and certified technicians, they are leaving the industry these years for retirement, and we don't get enough new young forces into the labor force. So we are in a very difficult situation. I heard at a webinar from the UK that in the UK they have around 1,000 refrigeration technicians and 120,000 working on boilers. If we are to phase out fossil fuels and exchange them with heat pumps, then you have the magnitude of people we need, and we are far behind already. So this is a big issue. When we look at the working fluids, they are classified, as you know, in the ASHRAE classification system, and we have different groups. I saw yesterday a new paper, not a new paper, it was from 2019, that some of these 2Ls, they are actually as dangerous or flammable as, for example, ammonia. So there's a lot of things we need to learn to do, and we have to be very careful. Another thing that I will come back to a little bit later is the illegal working fluids entering the market. And that is also a very dangerous topic because some of them contain flammable gases or even self-igniting gases such as R40 or methyl chloride. And this is a very difficult thing. And a lot of the low GWP gases are flammable depending on how you test it. You can of course test them so they are not flammable, but in reality they are. So be careful. And there's also a lot of new long-lasting breakdown products which will also put a new strain on our system. We have the ODP as a measure, we have the GWP as a measure, but perhaps we also need to look at PFAS in the long term. We need to find out how to do this. And remember that some of the gases, or all gases, they break down also without flame, means when they are exposed to ultraviolet lights, so or just heat from the room. So it is not so easy just to say that they are safe and not toxic. May I remind you that there is a lot of push for lower GWP, and it is coming from the EU regulation 517/2014, the F-gas directive, if you want, and the quota system, where the interest or the driver is to get to the lower, because then you can still sell more refrigerants. If you have a high GWP refrigerant, you can sell less because your quotas are given in CO2 equivalents. But this is another issue that we don't need to talk about here, but it gives you a picture of what is pushing. The workforce in the market, they need to phase down traditional working fluids, for example, the 134A, 44, and finally, also we see new refrigerants such as a new, not so much anymore, but to some markets it is new CO2 transcritical systems. They are becoming part of the new future systems. And also we see a lot of chillers using both A2Ls and A3 working fluids, which requires new certificates or training levels for the people working on the system. We also need to improve the certification of the engineers that are designing. We have to ensure that they are competent according to the EN 378. And may I remind you that to the EN 378 or ISO 5149, they are more or less identical. We need to be aware that the 13313 or the new ISO 22712, they show which requirements are needed for designers of the system. If you want to make service, what is needed, or if you want to do leak check, what is needed. This is a good guideline to what overall, but it's not a textbook that is needed to be done by the training institutes, but there is a lot of things that have never really been pushed hard enough in the market. So there is a lot of things to be done still. The certification system, they are in many cases up for renewal at the moment, and there is some bottleneck issues in some countries, but it's not a general thing because the certification systems are different from country to country. Also, the new temperature regimes, as I mentioned in the beginning, with higher temperatures gives new challenges. If we go over 120 degrees, for example, you need special certificate for welding on the pipes. On the secondary side, even when we go up to about 180 degrees, there will be another problem with the lubricants as we see it today. And also we need to move to very high temperatures seen with our spectacles today, because the EU foresees heat pump going up to about 250 or even 300. And to phase out at least some parts of the boiler market, and other parts of the boiler market will be serviced with hydrogen in the future. And it has to start now, because a lot of the equipment that is put in now will sit in the place the next 50 years, and that is a long time out in the future, and we will not be able to meet the 2050 goals if we wait until 2030 to do something, because of the longevity of the systems. So therefore, it's very important that we see this coming, and that requires a lot of skills from contractors, from technicians, from service technicians, but also we need to employ people that can work on the water side in the refrigeration business. So therefore, it is a very demanding future we are looking into. We recently, a couple of years ago, there was an accident in Canada where we saw the main issue was that the contractor had warned the owner that they had to exchange the heat exchanger, but they didn't do it. They put it into the budgets for 2 years, and then they fell out again. And after 7 years, after the first warnings and continued warnings, the thing exploded and 3 people were killed. And one of the lessons was that the owner had not followed the warning, and therefore he was guilty, and it became expensive for them because they had to pay. But it is very important that we don't only blame the contractor. We have to be very observing on the owners also. They have to have an obligation on them to know about what is it that they are buying, so they're not just holding up their hands and say, I know nothing and I'm innocent. That doesn't work anymore, and this is the future. We have to try to push this knowledge. Another sad story we heard just before Christmas, that we have not fully understood what happened, but from a quick reading and translation and explanations from the local field, I can see that it looks very much like an accident with these illegal refrigerants, wherein there has been R40 or methyl chloride, which has exploded and killed a service technician. And this is one of the things that we will look more into in the working group. The trouble is that it is very difficult to detect just by measuring pressure and temperature. You have to simply take a test of the refrigerant, and it's not so easy. But this was in December 2020, so it is not so long ago.
Alex, you have 30 seconds. Yes.
Yeah, in conclusions, to meet the expectations of the regulators in the society to get down, we need to do it in a safe and in the proper way. It requires a lot of certification, education, and we have to look into all the things that needs to be done. So in the future, there is a lot of things to do also for universities and training institutions and so on. Thank you very much for your attention, and if you have any questions.
Thank you, Alex. We will look to the Slido. At least one or maximum 2 questions. The first question: there are unknown environmental risks and safety risks with the new chemical refrigerants. How to give measures to these risks?
Yeah, it's a very good question. Thank you for that. It is not unknown that some of the breakdown products, they exist in the nature. We have seen tests of ice and snow in the Alps. We have seen on South what we call Antarctica, that these breakdown products are there. We need a measure on how to quantify how much each refrigerant can do. It is the PFAS directive that is looking into this, and how can we quantify how much each refrigerant participates. At the moment, we have no knowledge about this, so we need somebody or some institution to look into this. It could be for you, for example, to do this, but it's a new task.
Thank you, Alex. The time is over. I'm sorry. We have to continue with the next presentation. I would like to welcome Marek Zliczynski. Marek is a director, fellow researcher of R&D EMPRACO North America. In 2015, Marek was elected as the chairman of IEC International Subcommittee taking care about safety standardization for refrigeration industry. Marek, please take a word.
Good morning, everyone. Here in US it's quite early, but I'm happy to participate to this event as I did for several years till now. In my function of the chair of International Electrotechnical Committee's subcommittee SC61, I'm directly involved in the developing standards for refrigeration segment, and in particular I will talk now about the progress was done in recent time to handle the flammable refrigerants in commercial refrigeration. So as Didier presented, obviously the world is moving into the new era of let me say refrigeration in using less climate impacting products or compounds, but obviously when you talk about reduction of CO2 emission, we are going in the region of flammable refrigerants, and those refrigerants are obviously presenting additional risks that international legislation has to take into account. So the charge limit in the refrigeration are basically defined by two types of standards. There are so-called general standards and product standards. In international level, there are two organizations taking care of those standards. One is ISO, developing general standard, as Alessandro mentioned, is ISO 5149. And in product standard field, there's the International Electrotechnical Committee that my committee is up there and is taking care of the 20-24, so 335 series standards. 24 is for household refrigeration, and the -89 for commercial refrigeration. And this will be the main subject of my speech today. Each region or country have its own organization taking care of standardization. Like, for example, in Europe, we have CEN that is taking care of general standards, and CENELEC for electrotechnical standards, so producing equivalent standards to the global IEC standards. In US, we have ASHRAE that is, let me say, covering the part of general standard with ASHRAE 15 committee, and UL organization is developing the so-called product standards for the industry. In Japan, equivalent organization are the METI for the let me say general standard products, and Japanese Institute of Standards for product standards. And the same happening in Australia, New Zealand, in global level, and then in the product standards. So as I mentioned, there are two different level of standards. So general standard that is much broader, and then we have product standards. Product standards are mainly used by the manufacturer of equipment, because product standard basically contains inside its requirements, basic risk assessment. In general standard, not all the hazards are covered, so in the safeties depending on the location, on the who is present in the specific place. So is working on this installation mostly. It's not so much for the product that is produced in the big number, and then the manufacturer does not know where basically product will be applied, except obviously the instruction that is indicating what to do. Second thing, the standards are normally just a suggestion. Only the national authorities are can, well, let me say, require the compliance to the standard by their local, national or regional laws. And there is a rule of precedence that is written in all the general standards that if there is a product standard covering the certain subject, has to be used in preference to the general standard. So if you have the cabinet that is, well, let me say, going to the supermarket, there is a product standard covering it, so you have to apply this product standard. In 2019, my committee proposed the new standards dealing with flammable refrigerants for commercial refrigeration, and after quite difficult, let me say, path, was approved in June 2019. This standard is covering basically most of the cabinets used in commercial refrigeration, bottle coolers, ice cream freezer, other refrigeration equipment used in the shops, restaurants, or supermarkets. And in addition to the scope was larger to ice makers. So ice makers are now covered by this new -89 standard. Some of the system are not covered by 89 standard because or they are excluded from the scope, so like the walk-in rooms or let me say walk-in display cabinets, or kind of the food dispensing equipment, they are covered by this 75 standard of this 335 series. With this new standard, the maximum charge level was increased from 150 grams to 13 times LFL, but not. What does it mean 13 times LFL? LFL is low flammability limit, and here you can see as an example of, in case of propane, 13 times LFL is almost 500 grams or half a kilo as a maximum quantity. In case of R32, for example, this A2 class, safety class, even if the formula gives almost 4 kilos, let me say, an international committee decided that 1.2 is enough because can provide the same cooling effect as half a kilo of propane. This limitation is still under discussion. Probably in the next revision of the standard, this limit probably will change. Important to say that for the system below 150 grams, the requirements are the same, so you have no any additional requirements for the system under 150 grams. The requirements, new requirements, are basically only related to the system with higher, above 150 grams. As I said, ice makers are covered, and remote systems are excluded for the moment from the scope. And this is something else that probably will change in the next future. So here is a list of new requirements for the system with the charge above 150 grams. So there are the system has to be hermetically sealed, protected, and not accessible to avoid damage, cannot cause vibration or resonances, and has to be marked with the new symbol on the appliance that will avoid placing of the equipment in the room that is too small, that can cause the stratification of the refrigerant in case of leak. But the most important point to assure the safety of the system with higher charge is to minimize the risk of creation of flammable refrigerant around the appliance in case of leak. And this, let me say, concentration can be avoided by using basically airflow. It's not really mandatory to use a fan, because if in case you have the system placed on the top of appliance, fan may be not necessary, but in most of cases the appliance itself has to provide enough airflow to minimize this risk of flammable concentration in case of leak around the appliance, because you can imagine that you can have a new appliance with higher charge surrounded by system that what has potential, let me say, ignition sources. So the most important thing is to prevent a risk of creation of flammable cloud in the surroundings of the appliance. And there's an Annex C in the standard that is, let me say, designed to test each appliance in this regard. One of the most difficult tests is the door opening. So imagine you have the release of all the charge inside the cabinets with doors, and then suddenly you open the door. So basically you can see much more easily the high concentration in the surroundings. So this is probably the most difficult test to pass. So maybe some of the application with 500 grams with doors will not pass this kind of test. So, or the manufacturer will, let me say, create a special airflow to mitigate this risk. Now, as you know, ISC standard is, let me say, suggestion for all the world. No? So is the starting point. So this new edition with the higher charge limit basically was adopted in many countries that they have their own standardization system, but in the regions where there is a strong local or regional standardization, the process is still ongoing. So first of all, in Europe, this new EN version of the standard has to become a harmonized standard with machine directive, and this is quite in delay because of alignment with directive. So the last date I got from the Chenelec Technical Committee 61 is the target date for final vote, probably in October, November 21. In US, the equivalent proposal was already developed, but working group 12 of Canina, I'm part of this committee as well, and this is going in the comment periods in this moment, and the publication is expected in still in this year for US and Canada. In New Zealand, Australia was the quickest one to approve it in their local standardization system, and this was done in July last year. As well, Japan has the working group in Jiraiya working on the Japanese version of the standard with deviations. This similar deviation was done in the proposed US version. So we have no clear idea when really the Japanese standard will see the light. So anyway, the committee 61C, in particular working group 4 that is in charge of the standard, is now working on new amendment to try to improve the standard for the future. How, in the objective to handle safety the flammable refrigerants, that is the let me say one of the ways to reduce the carbon emission globally. Thank you very much. I'm open to hear the questions. Thank you.
Thank you, Marek, for the presentation. We are going to look to the Slido. There are two questions. Can we expect increasing allowable charges for propane or HFCs also in air conditioning and heat pumps? For example, cap limit M1 from 1.8. For example, I think it means refrigerants are 32, 1.8 up to 2.5 kilograms.
Yeah. This is important. What I was explaining today is the product standard. Okay. Today, in air conditioning heat pumps, there is another standard, is -40, that is already having much larger charge of flammable refrigerants. So, for example, propane, in the certain situation, even more than 1 kilo. Okay. In case of air conditioning, A2L refrigerant, this limit is even larger. Okay. So if you go to the specific air conditioning heat pumps, the limits are already much higher than we have in commercial refrigeration. Okay.
Thank you, Marek.
Yeah.
Yes.
No, go ahead. Thank you.
Yes. Only one question, because we are behind. The time is over. So and the next section starts at 10:30, and we have to prepare them. So it is the end of plenary session. Dear friends, it was the last paper, and we are going to continue. I would like to pay your attention to that you have now access to video with all presentations in plenary part. It means you can follow them again. If you do not want to follow the video from plenary session, you should go back to lobby. It means to click on the button back to lobby. At 10:30, it means in 15 minutes, you can join one of our 4 parallel sessions, morning sessions with 22 presentations. You can join parallel sessions through conference lobby. Complete program you can see in the conference lobby, because I pay attention to it, because we had connected some participants to us, to the authors, but you should be connected as participants to conference lobby. From conference lobby, you can join whichever of 4 parallel sessions and whichever presentation. You can move among sessions. You can click on whatever presentation and follow it to give questions through Slido. After the 4 parallel sessions, we will continue at 13 o'clock with invited paper on hydrogen applications and hydrogen storage. At 13:30, you will be welcomed on the IAR Commission's meeting, which will be moderated by Didier Coulomb, the director of IAR. At 15 o'clock, we will start the next 4 parallel sessions with 16 papers. And at 17 o'clock, we will start conference closing. What you can see here on conference closing, we will speak about conference statistic. There will be commemorative medals of Avril Stodela will be granted. Best conference papers will be announced, which will be recommended for International Journal of Refrigeration. Ceremonial act of handing over the honorary position of the conference president will be carried out. And IR conclusions from IR Commission's meeting will be presented, and the next conference date will be announced. And last comment, you can still reach conference proceedings and conference video if you haven't ordered it You should only register on the website, on our website. You can find it, registration through conference lobby. Dear friends, enjoy the coffee break, and you will be welcome on next 4 parallel session at 10:30. Bye-bye.